Chapter 12 is our probability section. So we're going to split this up into basic probability for 12.1, then we're going to look at the normal curve and the binomial distribution. We end this chapter by looking at some counting, permutation, combinations, how many ways things can be put in order. Okay? So 12.1, basic probability. How do you find the probability of an event happening? And probably the most important thing for probability, basic probability, is topic over total. Finding your total, how many possible outcomes there could be, how many ways something can happen is extremely important. Once you have that, now you just need to think about what do we find the probability of. What we're finding the probability of, that's going to be our topic. Okay? Two rules we're going to talk about. The first one is the addition rule. Okay? And the key word to know you're using the addition rule is or. One action is happening. Okay? You're rolling a die and either a 3 or a 4 is going to happen. You're pulling one card out and either the card is a heart or a spade. Okay? One event is going to happen and you have options of what that event could be. Okay? What is the chance of rolling a 3 or a 4? So the key word here, we see it as or, and rolling a 3 or a 4. So now you just have to think, what's the probability of rolling a 3? Rolling a standard die, there's 6 sides, and there's 1 3. 1 over 6. The or means we're adding. 4 is going to be 1 over 6 as well. Okay? And add those together. I want your answer in probability as a percentage. So this would be 33.333%. Put it as a percentage, add like 3 decimal places. What's the chance of rolling a 5 or a number lower than 3? Just again, the key word is or, so we know we're going to be adding. Just think about what the situations are. Rolling a 5 is 1 out of 6. There's 1 5 on the 6-sided die, and a number lower than 3. Okay? That's either a 1 or a 2. So just think about it. Number lower than 3. 3 is not lower than itself, so it's just 1 and 2. 2 out of 6, which this gives us 50%. Okay? So thinking about the keywords and thinking about what each topic or what each situation is. Okay? Now, for the addition rule, what we just looked at, we looked at mutually exclusive events. These are events that cannot happen together. And we just did the basic probability of probability of A, that's what the P stands for. This is notation for probability. Probability of event A plus the probability of event B. Okay? And just added those together. What's the chance of pulling a 5 or a king from a standard deck of cards? Now, the key word there again is or. So we know it's on be the addition rule, and now we have to think, can that 5 and king happen together? Okay? You can't get a card that's a 5 and a king at the same time. So these are mutually exclusive events. 4 out of 52 plus 4 out of 52. There's 4 5s, there's 4 kings, and this should give us, we're going to have our calculators to do this work for us, 15.385%. Okay, 15.385%. Now, not mutually exclusive events. These become a little trickier. These are events that can happen together. Okay. Probability of A plus the probability of B minus probability of A and B together. Okay. We need to worry about this A and B together because things are going to be counted too many times. If things can happen in both probability of A and B, there's overlap. Okay? So we need to think how many times can they happen together because then we're going to take that away. So the example I have here, picking a heart or an ace from a standard deck of cards. Well, there's 13 hearts out of 52. There are 4 aces out of 52. Now, the ace of heart is overlapping. That's why these are not mutually exclusive events. You can get a heart that's also an ace. Okay, so that's why we have to think about this probability of A and B happening together. Okay, if you think about it, that heart is being counted here. The ace is being counted here. It's being counted 2 times. So we need to take one of those away. Take one of those away so it's not inflating what our probability is. So there is 1 heart that's also an ace. So I'm subtracting 1 over 52. Okay? Again, let the calculator do that for you. 30.769%. So there's the addition rule with some basic problems, the basic formulas that we have here. Mutually exclusive is probability of A and the probability of B. For not mutually exclusive, probability of A plus the probability of B minus A and B happening together. And now here we have favorite pizza. We have either thin crust or deep dish, and then toppings, mushroom, pepperoni, or plain. Now, don't overthink these problems. Okay, I don't want people to start saying, well, you can get half pepperoni, half mushroom. Just very basic. Your favorite topping is either mushroom or pepperoni. Okay? Now, I said the most important thing about probability is topic over total. So the first thing I would do in this situation, find the total of each row, find the total of each column. So I have 102, 150, 83, 166, and 169. And add those together to get our grand total of 335. Now make sure you're only adding our grand total up once. Sometimes people add up all the rows, all the columns, all the rows together, and they end up doubling the grand total. Take your time, remember, you just want to add everything up once. Okay? Now these problems look the same. What's the chance of getting a deep dish or a plain? I'm sorry, this is kind of going over our answer here. There's our keyword or. Now, deep dish goes across, and that's going to be 169 out of 335. Plain's going down. That's going to be 83 out of 335. Now, you have to think, can you get a deep dish pizza that's also plain? And the answer is yes. Okay, there is such thing as a deep dish pizza that's also plain. So, and also look, deep dish is going across, plain is going across. They intersect, and they intersect at that 48. Okay, that's how many times those two events can happen at the same time. So that 48 is being added once with the deep dish, it's being added once with the plain. So we have to take it away one time to balance everything out. 48 over 335, and that should give you 60.896. 60.896%. So that was considered not mutually exclusive events, events that can happen together. Now what's the chance of picking a mushroom or a plain? Well, mushroom's going down here at 102. Plain we just looked at is 83. Now I said don't overthink this. We can't get a mushroom pizza and a plain pizza at the same time. Don't think about getting half and half. Okay? It's either mushroom or it's plain. It cannot happen together. And also look, the mushroom's going down, the plain's going down. There's no point of intersection. Okay? So they cannot happen together. So there's our problem. There's nothing to subtract because they can't happen together. And I have 55.224%. Okay? 55.224%. So you have to think, can the events happen together, and think about how I thought about it. Going down means they don't intersect, so there is no cross section, nothing to subtract. For the deep dish and plain, there was intersection there. And one more example. Here we're looking at there are 125 11th graders and 115 12th graders at Moores High. Of the 11th graders, 70 are part of a club or sport. Of the 12th graders, 80 are part of a club or sport. What is the chance of picking a student from this group at random and having that student being an 11th grader or someone who's on a club/team? Right? Keyword is or. Now, our total here, if you add up our 11th and 12th graders, our total is 240. Right? Now, first one is 11th graders. So there are 125 11th graders. Now the keyword or, so I know I'm adding it together. People who are a part of club and sports team, you have to put these values together. 70 11th graders, 80 12th graders, so I'm putting them together for the 150 out of 240 are a club and sports team. Now, this is where there's no columns, there's no table set up. You need to think, can the events happen together? Can you get an 11th grader that's also part of a club or sports team? The answer is yes. It can happen, and it happens 11 times. So I'm going to subtract that. Now, I'm hoping you guys maybe even thought, okay, well, how about I just don't add those together? How about I just do 80 over 240 and add that? Because those 70 are already a part of that 125 there. That's a way you can think about it. I'm probably showing a little more work than I have to for this one. That's it. That's exactly what we're doing though. We're taking that 70 away. If you take that 70 away from the 150, that is 80. So you're doing that same work. You're just kind of skipping ahead and doing it before you actually put it all in the formula, if that's the way you thought about it. Okay, so that's good if you think about it that way. Your final answer should be 85.417%. Okay? So there are examples of the addition rule. Okay, the key word is or. If you see or in that statement, you're going to be doing some kind of addition. How many actions are there? One. One action with multiple outcomes. Okay, so the second video then will finish up this section, and it's going to be the multiplication rule.